Hi everyone, this is my voiceover of Laplanda Tech Programming in LabVIEW videos that I originally created for my overseas audience, and now since there is some interest from my Silicon Valley community, I decided to quickly translate it. We continue working with the database tool. In our DB tool, we use pre-programmed SQL commands, SQL functions, and at the same time, we also have an option in our program to form SQL commands directly, which then talk directly to our databases. I run our program, and here we see the SQL query button. Here you can see the SQL command that we formed last time and compared it with the automatic function that is executed by pressing the Replace Cell button. Today we'll continue comparing our programmed SQL functions with direct SQL code, but here I want to pause for just a minute. You probably noticed what I have in the background. This is the moment where engineers stop listening to marketing slides and start watching the actual tool. In some of the comments you ask, why do we use this program? What is this program that we are working in right now? And why don't we do the same thing, for example, in Python or in text-based programming languages like C or others? Which, if I translate from your language, really means, why are you not suffering the way I'm suffering? So I think it makes sense to take a short detour and do a comparison. So we're developing our database tool using a modern object-oriented programming language called G, which was developed and introduced in Laboratory Virtual Instrument Engineering Workbench in the environment that is now called LabVIEW or LabVIEW IDE, Integrated Development Environment. This language uses functions that are written in C++ and designed in such a way that all blocks can be integrated into the code seamlessly, which means under the hood it's fast and on the surface it's readable. Engineers love that combo. Now let's look at one of the functions we discussed in the previous episode, saving a data array into a spreadsheet file. It's located inside the sub-VI, so let's look at it. The sub-VI is inside the save.txt case, and it's called db table save. Here's this function, and let's see what it is in context help. Write delimited spreadsheet converts a 2D or 1D array of strings, signed integers, or double precision numbers into a text string and writes the string to a new byte string file or appends the string to an existing file. Wire data to the 2D data input or 1D data input to determine the polymorphic instance to use or manually select the instance. So this function is written in C++. Now let's see what it would look like if we were using a text-based programming language. We have such a wonderful tool as ChatGPT, so let's ask it to generate this function in C++ for us. Because every engineer now has an AI intern with unlimited confidence. By the way, in order for ChatGPT to generate it correctly, we'll take the description directly from LabVIEW. If we open context help and then detailed help, we get this full reference with all the functions and detailed descriptions. I copy that and paste it into ChatGPT. So now we have C++ code, and I can immediately tell you what is missing in this code. We are missing the terminals that we're used to. In text-based programming languages, these are called arguments. In LabVIEW, you see them. In text code, you remember them, or you don't. Now let's ask ChatGPT to add 2 or 3 arguments. I type modify arguments needed, variable for path where the array will be written, including the file name, variable for array input control, variable for creating the file if needed, variable with the error output, variable control for transpose the array. Let's see what we get. We copy the code and paste it onto our block diagram. Okay, let's take a look. This is here. This is here. Well, let's assume it works. Classic engineering optimism. But that's not the point. I did this just to show what kind of code is actually hidden inside our right delimited spreadsheet function. Just realize that one block is hundreds of lines you never had to write. And as you can see, with ChatGPT, we can now easily generate code in text-based languages. But what's the catch? The problem is that we can create simple programs, yes, but when something more complex is needed, especially when you need to modify or extend functionality, and especially if you need to connect hardware, that's where ChatGPT will start having problems. Using our object-oriented programming, we can make the code more complex almost infinitely. We can connect any peripheral devices, because practically there are no devices that do not have LabVIEW drivers. If we go up here and open the menu Instrument I/O, we can see all kinds of drivers. For example, let's take this one. And I don't have any additional drivers installed here yet. This is just the standard package that I'm showing you. But for example, if I need to communicate with the instruments, the Visa driver is already installed. All that's left is to connect the instrument to the computer and use Max, Measurement and Automation Explorer. If we go to Devices and Interfaces, we'll see the device automatically detected by the Visa driver. All that remains is to check the connection parameters, and then we can work with this instrument directly from our computer. The LabVIEW development environment supports practically all peripheral devices, because almost all manufacturers try to meet National Instruments requirements. National Instruments is now part of Emerson, but okay, I'm getting ahead of myself. We'll talk later about how to work with peripheral devices, and we'll even go down to the microchip level, firmware creation, flash and microcontrollers, but all of that later. Right now we are talking about databases, but I still want to finish the comparison. Our functions are written in C++, which is perfectly adapted for working with peripheral devices and is considered one of the fastest programming languages. For example, processing large archives in Python will take significantly more time than in LabVIEW. You can say that Python politely asked for a coffee break, while LabVIEW already finished the job. So let's still look inside our function. Okay, this first code block that I placed here has no arguments, so I'll delete it. We don't need it. As you can see, we created the function quickly and easily, but the most important part comes next. Now we need to integrate it into the code, and this is where problems start. ChatGPT can't help us here, and I'll allow myself to make this conclusion. It might make some people angry. I don't want to offend anyone. Please comment on this topic, by the way. But text-based programmers hate us, the ones who move to the next level, because spending months digging through the text and looking smart doesn't really work anymore when we can do the same thing in a day without much effort. So, my humble advice to text programmers, while it's not too late, reorient yourselves. Otherwise, retirement won't be very comfortable. There's probably no point in continuing to list the advantages of our object-oriented function compared to its text-based implementation. So I'll delete everything here. Still, to finish this section, you already saw 3 identical programs on my screen, written in 3 different languages. Let's first look at the program written in C#, made in Visual Studio. I closed the GUI, it complained at me a little. And now let's look at what this program consists of. This is a project we created, a simple calculator that performs 3 operations: multiply, divide, and sum. What files participate in the project? On the right side, we see Solution Explorer and all the files included in the project. We won't analyze each one in detail. Our goal is simply to see and realize how much work is required to write this tiny program. Something looks a bit misaligned here. Everything I moved around here is automatically reflected in form1.designer.cs. This file contains all UI-related changes. And here we have the algorithm. We won't analyze it today, that's not our topic today. Let's run the program and see how it works. And let's test it. As we can see, it works. So now we have a rough idea of the workload in C# Visual Studio. So we reviewed C#. Now let's look at Python. I'll close this. The interpreter is somewhere in the background. I run the program. Oh, here it is. Let's test this program now. All buttons work. We can close it now, but again, we can see how much code volume this small program takes. Now let's look at LabVIEW. The same program. We run it, test it. Everything works perfectly. Let me bring it here so it's easier to see. Let's look at how this calculator works on the program level. If you remember the amount of work required in text-based programs to create such a small application in C# and Python, now look at this. Here we use the object-oriented programming language G. Let's go through the block diagram and see how intuitive this code is. Here you see 3 buttons, 2 variables, and 1 indicator, result, which shows the calculation result. Here we have 3 cases, 1 for each button. Each case performs its arithmetic operation. When false, nothing happens. The variable value doesn't change, and it's continuously written to the result indicator at the rate I set here. 500 milliseconds or half a second, which means twice per second. As soon as we press one of these buttons, that case becomes active and the arithmetic operation is performed. The local variable is updated with this arithmetic value, and then the same loop continues because all cases go back to false. The first button, let's look at it, for example, multiply, and as soon as we press it, it switches to the true case and then goes back to false. The same thing happens with the divide button and with the plus button. Sum, yes. And here we have our local variable, and basically everything is very logical, simple, and hard to make a mistake. If we want to use this somewhere else, we can create a function out of it. To do that, I'll just create a sub-VI, which will act as this function. I stop the execution of the program. That's it, I created the sub-VI, and now I can use it as a function in my further developments. I'll open it and show it to you. Here it is. I return everything back to its original state, and well, yes, we've already spent too much time on comparisons, so let's still return to our database tool. Let's perform an operation. In the previous episode, we started looking at the replace cell function. Let's quickly revisit it. Suppose we use our program tools, our replace cell function, and replace a value in the table. For that, I run the program, select the table. It happens almost instantly. Let's say I want to change 999 to 888. I press replace cell, replace in one cell. Now let's see how the same thing is done using direct SQL code. We press the SQL query button, and here we have the SQL command. Update the table, set a value where index ID equals something and voltage equals something. So here we have three conditions, where, and. And of course, there could be more. I know that this cell had the value 999 and now it's 888. I want to change it back, so I carefully verify all the values, the index, the voltage, the table name. Here the number is in engineering format, 999.25 to the minus third power. Everything must match exactly. We send the query and the value changes. But the probability of making a mistake here is very high, and you have to be extremely careful. And one more thing, why do we have this field at the bottom where we duplicate the table name? Our program is independent of SQL execution, so we need to tell it which table we want to refresh so that we can see the changes. Here we have two buttons, send query and cancel. Cancel does nothing, send query executes the command. Let's do it again to make sure it works. For example, we change it to this value. Here we currently have 999.25 to the minus third power. Yes, everything is correct. We send this query and it's changed, yes. So now let's look at how our button works on the program level. We find the case that is controlled by our button. Oh, I turned the program off? Well, okay, I'll run it again later. So, replace cell. If the program is turned off, I can actually get to find terminal very easily and go straight to this case. So here, what do we see? Don't be scared, this is all very basic. We'll go through it in detail later. And right now, what we are interested in is the SQL command. It is located in the sub-VI called dbReplaceCell. Actually, I do need to start our dbtool program for the next actions. I do that quickly, return to the same table where I was, and once again replace the value with the number that was there before. I choose replace in one cell. So now we place a probe. We place a probe after the concatenate strings function, and we change the value here again, then press the button. And we see that the value in the cell has changed, and we can see our SQL code. And now we will compare it with the code that we used in SQL query. Update test station, set current value, where and index ID and voltage V. That is, we have just executed the same command, but in two different ways. In the first case, direct SQL. In the second, a programmed function. Same database result, but one path involves trust in your architecture instead of trust in your typing skills. And even though at first glance the logic may look complex, once we create it once, we no longer worry about making mistakes in SQL syntax. Let's look at one more command today, replacing all identical values in one column. Let's place another probe. Let's say I want to change a date from the 20th to the 21st, and I want to replace this date in all cells that contain it. I change one cell, press replace cell, replace in all cells, The program tells me how many values will be replaced. 3. And we even have an extra feature. All replaced cells are highlighted. Now, let's do the same using SQL query. I copy the command from the probe display, paste it here, and change the value back. We send the query, the database value changes, and automatically the program updates the table state on the user interface. Even though it looks like we only changed the local table, the changes were made in the database. I now press the button Refresh Table, and the database table is updated again. That's probably enough for today. Thank you for joining LaPlante Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.